Segment 4, Networking and Content Delivery. In this segment, we are covering one of the most important topics for AWS Cloud Practitioner, networking and content delivery. We will understand four services: Amazon VPC, Route 53, ELB, and CloudFront. And trust me, if you understand the relationship between these four services, many exam questions become extremely easy. Let's start with the foundation of anything and everything: Amazon VPC. VPC stands for Virtual Private Cloud. Think of VPC as your own private network inside AWS, where you launch and secure AWS resources. Just like your home has walls and rooms, AWS gives you a private network where you can securely launch resources such as EC2, RDS, and Lambda. Key points: private network in AWS. This is the first thing to remember. Whenever AWS asks where your resources live, the answer is usually inside a VPC. You can launch EC2, RDS, Lambda inside a VPC. VPC also support public and private subnet. A public subnet can access the internet. A private subnet cannot directly access the internet. AWS uses security group and NACL to protect traffic. And remember, VPC is regional service. One VPC belongs to only one AWS region. Let's come to the diagram and see how VPC works. Imagine a company website. The web server EC2 is placed inside a public subnet. Why? Because users need internet access. Now, imagine the database. We don't actually want our customers directly connecting to the database, so RDS is put under private subnet. Internet coming through the internet gateway. Traffic enters the VPC, then it reaches either the public subnet or private subnet depending upon the configuration. So remember, public subnet internet access, private subnet does not have direct internet access. So components to remember: VPC is for private network. Subnet is just the smaller network inside VPC. Internet gateway is internet access. Route table controls traffic. And security group, instance firewall, that is stateful. NACL, it is subnets. Firewall, that is stateless. Now, quiz time. Which subnet is directly accessible from the internet? Private subnet? No. I don't know about isolated subnets. So the answer is public subnet. Which VPC component works at the subnet level and it is stateless? Subnet level and stateless, that is NACL. This could be one of the favorite AWS questions, so mark it. A company wants to block all inbound traffic to a subnet. Which component should they configure? Again, NACL. Resources in a private subnet need internet access for update but should not be accessible from the internet. So some services in the private subnet need some internet, but user should not reach the private subnet directly. So they uses NAT gateway. So exam goal: VPC private network as discussed here, public subnet internet access, private subnet database layer, security group that is stateful and is instance firewall, NACL subnet firewall that is stateless, and internet gateway is internet connectivity. One line memory trick: just assume VPC is your house, subnets are rooms, security groups are door locks, and the internet gateway is main gate. Now that we have built our network, the next question is simple: how do users find our website? So with this, we reach to Amazon Route 53. Route 53 is AWS DNS service. DNS is domain name service system. Humans remember names. Computer understand IP addresses. Route 53 translates between the two. So, example. You type www.amazon.com. But the server actually has an IP address. Route 53 converts the domain name into an IP address. That is why it is called DNS. So, key points. DNS Web Services, domain registration, a scalable and highly available. Route 53 also supposed to have health checks. It also have routing policies, also works with other AWS services, and it is a global service. So how actually it works? User enters a domain name. Route 53 looks inside the hosted zone. It finds the DNS record, returns the IP address back, and browser connects to the server. Simple. Now, DNS record type. It is exam focused. You can expect one or two questions around this. A record maps domain to IPv4. A record maps domain to IPv4, and it is one of the most important records. 4 times A record, it maps to IPv6. Single A IPv4, 4 times A is IPv6. CNAME maps one domain to another domain. Example, www.example.com points to example.com. Now, MX. Used for emails. Whenever AWS asks about email routing, think MX. NS is a name server record used to identify DNS server. And finally, TXT that stores text information, usually verification records. Next is the routing policy. So, simple routing. It is a default policy. Routes traffic to one resource, that is one destination. Now come to weighted routing. It distributes traffic based on weights, that is traffic distribution. Latency routing. Lowest latency region. Routes user to lowest latency region. Then comes the failover routing. Automatic failover to backup resource. Then geolocation, route based on user's geographic location. Geo-proximity routing, route based on location as well as resource. Then the last one is multi-value answer, return multiple healthy records. You can expect at least one question from this. Most of the cases they ask one or two questions around this. Now, we have already seen components to remember: domain, hosted zone, record, set, record, health check, traffic flow. This could be example. How does it work? A record work. Now the quiz time. So, domain to IPv4. Which records type is used to map a domain name to IPv4? Domain to IPv4 is A. Which record type should you use to map one domain to another domain is CNAME. You want email for example.com to be delivered to mail.example.com, it is MX. And then, which routing policy routes traffic to the region that provides the lowest latency? When it is talked about latency, just tick latency routing. So, exam gold. Route 53 is a DNS service. Translate domain name to IP address. Health checks ensure availability. Routing policy control traffic flow. Global, highly available and scalable. And one line memory trick. Route 53 finds the right destination IP for your domain. Now, users have found our application. What happens if millions of users arrives at the same time? That's where Elastic Load Balancer comes in. So, ELB stands for Elastic Load Balancer. Its job is simple. Elastic Load Balancer job is quite simple. It distributes traffic across multiple servers, like a traffic police handling the traffic. It distributes traffic across multiple servers. Instead of sending traffic to one EC2 instance, ELB spreads it across multiple instances. And a real life example could be, imagine one wailing counter in a supermarket. Huge queue, slow services. Now imagine 10 counters. Customers get distributed. Everything becomes faster. That's exactly what ELB does. So, the key points. Elastic Load Balancer distributes traffic across multiple targets. It also improves availability and makes the system fault tolerance. It also checks health automatically. It scales our application, supports multiple ELB types, works across multiple AGs, and you only need to pay for what you use. So, Coming to how actually Elastic Load Balancer works. So, user sends the request, ELB receives request, and then ELB checks health of the server. Healthy server receives traffic, unhealthy server is removed automatically. This is very important exam concept. ELB types. First one is Application Load Balancer. Layer 7. Application Load Balancer lives on layer 7, that is also known as application layer. It is related to web application mainly. NLB, Network Load Balancer. It is associated with layer 4 and it is a high performance and low latency load balancer. And another one is Gateway Load Balancer. It exists on layer 3. It is for security appliances, firewall, third-party application. So you could be tested upon protocols and you can expect 1 to 2 around this also. Now, coming to the quiz. Which ELB works at layer 7? Layer 7 is Application Load Balancer. It have HTTP protocol. Which ELB type is best for ultra high performance low latency? Network Load Balancer, because latency has been talked. If an EC2 instance behind ELB fail health check, what happens? ELB stops sending traffic to that system and it closes that system automatically. Which component is a group of targets that ELB route traffic to? Target group. Exam goal. ELB lives on layer 7, NLB lives on layer 4. Health check is healthy server gets traffic. Now, user can now reach our application and traffic is also balanced. But what if users are located all around the world? How do we make content load faster? There comes the Amazon CloudFront, also known as CDN Content Delivery Network. CloudFront is AWS Content Delivery Network, CDN. Whenever you see CDN in the exam, your answer is most probably CloudFront. Its purpose is to deliver content faster to user. Let's see a real life example. You have a website that is hosted in Mumbai, India server, and a user opens it from London. Without CloudFront, every request goes all the way to Mumbai with higher latency. But with CloudFront, a copy is stored closer to London, that the content loads much faster. So, coming to the key points. It is a global service and the key is content delivery network. Reduces latencies and improve performance. Secure content delivery could be integrated with S3, ELB, EC2, media store, etc. It uses edge location to cache content and supports HTTPS, SSL, TLS, works with origin and also pay for what you use only. How CloudFront actually works. User request content. CloudFront checks edge location. If content exists there, serve immediately. If not, fetch from origin. So, and store in cache. Then deliver to user. Future requests become faster. What are the component? So, edge location. Edge location is the global location to cache content closer to user. And by caching, it reduces load on origin and improve performances. Kind of secure also. It has distributed denial of service protection integrated with AWS Shield. You can put up your custom domain and origin flexibility is also there. Common use cases. Website acceleration, video streaming, software downloads, static website, global application. Coming to the quiz. What is CloudFront? CloudFront is a content delivery network. Netflix uses this. Where does it fetches its content from? It fetches its content from edge location. If found, then good. If not found, it goes to the origin, fetches it, store in cache, so that the request for other user could be served faster. Base services can be used as an origin to CloudFront. S3 could be used as an origin to CloudFront. Please note that this type of question could be found in exam, where you might see it as confusing, but you must remember. Which feature helps secure content access? Could be assigned URLs and cookies. So, coming to the final summary. Let's just quickly revise. VPC is virtual private cloud and builds the network in AWS only. Supports public and private subnets, route tables, internet gateway, security group, and NACL. Route 53 finds the destination, domain name service, supports record type A, 4 times A, CNAME. A is for domain to IPv4, 4A is for domain to IPv6, CNAME is for one domain to another domain, and so on. Elastic load balancer balances traffic and improves the availability. Then comes the CloudFront. It delivers content faster, caches content globally. One line memory trick. VPC builds the road, Route 53 finds the address, ELB manages traffic, and CloudFront brings content closer to the user. You can go through the exam practice, test yourself, and if you remember just this single line, you will solve a huge number of AWS Cloud Practitioner exams. So the exam goal is for VPC, private network, subnet, security group, NACL, routing. Route 53 finds the addresses, it is a domain name service thing. ELB manages the traffic, its types are ALB that lives on layer 7, network load balancer on layer 4, and gateway load balancer lives in layer 3. CloudFront, global CDN, and one line memory trick is, as already said multiple times, VPC build a network, Route 53 finds it, ELB balances the traffic, and CloudFront deliver it to the user very fast.